Welcome to our day 4 lecture in Upward Bound Integrated Math 2. Today we're going to start looking at systems of equations, and we're going to use elimination today. There's really 3 ways in most algebra-based classes that we teach solving systems of equations. One of them is by graphing, one of them is by elimination, and another is by substitution. We're actually going to cover elimination today and substitution next time. I kind of skip over in this class the graphing idea just in the sake of time. But our main idea with systems of equations is just to figure out where our 2 lines are going to cross. Okay, we're going to have 2 lines from 2 equations, and we want to know where those lines cross. So we do. That kind of hints us to the idea that we do need both an x value and a y value. We're looking for a point where the 2 lines cross. Okay. The steps involved with that, you can read through those for the most part. But I want to make sure that I have the way I think of this is I have my x's, my y's, and my equal signs. Usually if I do those 3 things, everything else falls in line. I want them all stacked in the 2 equations. I want them stacked on top of each other. So I want them stacked on top of each other. Then I'm going to multiply, these steps are the complete list of steps, and then what you need to do is kind of based on what you have. Like, you may get to skip one of these steps, or you may kind of tweak one of these steps a little bit to get to your solution. But the second step is multiply one or both of the equations by a number to obtain coefficients that are opposites for one of the variables. Then you want to add, and I'm going to say add or subtract the equations that you get from step 2. We'll talk about that in a second. In step 3, you're going to add or subtract the equations. Then you're going to get, the idea there is that you've eliminated a variable. And so then you've got an equation with 1 variable, which you can solve, and then use that solution in one of the other equations. So this is where it gets a little confusing. Use that solution in one of the other equations to solve for the other variable, and then check your solution optimally. I went ahead and did the first 2 problems ahead of time just to make this go a little bit quicker. But we see here, let me get this out of the way. So we see here we've got 3x minus y equals -6, and 6x plus y equals -12. I'm going to go ahead and add those equations because my 9's are matched up. They're actually opposites of each other. My y's are going to cancel each other out just by adding these 2 equations. And that's a good thing. That's what we want to have happen. So when I add those 2 equations, my 9's cancel. I get 3 plus 6x, which is 9x, and -6 plus -12, which is -18. So this is really my step 3 in action. Step 3 says to add the equations, and like I said, or subtract. But I added the equations. I get an equation with 1 variable. I can solve that for x. Okay, if I ended up canceling out my x's, I would solve for y. There's no real difference there. And then I get x equals -2 in this case. Then I pick the top equation, and instead of having an x in that equation, I go ahead and plug in my -2. And then what do I notice? I've got an equation with just 1 variable, which we've worked in the past on how to solve that. So I multiply 3 times -2, get -6. And when I do that algebra, I get y equals 0. So add 6 to both sides, I get -9y equals 0. When I divide -9, I still get 0. Okay. The other style of problem would be if, and there's a lot of controversy on whether this is even a case, or like these steps up here would never result in this being the case. And I'll get to that in just a second. But in this case, what I see is I see my y's are the same. So before they were opposites, and now they're the same. They're both negative 7y. So if I add them, that's not going to work out. If I add them together, I'm going to get negative 14y. That didn't cancel anything out. But I do know that if I take a number and subtract the same number, I get 0. So if I subtract these two equations, those will cancel. It's a little bit tougher because I do have to know that I'm going x minus 3x. So in that case, I'm kind of looking at 1x minus 3x. And that gives me my negative 2x. And then over here I'm going, this is where it can really get confusing, negative 24 minus negative 16. Well, that minus a negative turns into add a positive. And I get negative 24 plus 16. That gives me my negative 8. But then I get just an equation with one variable. It's a one-step equation. I divide by negative 2 on both sides, and I get x equals 4. Then I took the original first equation. So I took the original first equation and plugged in my 4 for my x. And notice that whenever I substitute something in, I'm going to put it in parentheses so that I know that's my substitution. It just makes it a little bit easier if I get a weird answer, I don't think the answer matches, I can go back and look, make sure that I substituted the right thing into the right spot. Okay, but then solving that equation, I would subtract 4 from both sides. Subtracting 4 from both sides gives me negative 7y equals negative 28. And then I can divide both sides by negative 7 and get y equals 4. So both x and y equaled 4. So if I were to graph these two lines, which it wouldn't be a pretty result, if I was to turn these into like slope-intercept form where I could graph them, it wouldn't be that neat of an equation. It would be really ugly. But it can still be done. The two lines would actually cross at 4, 4, which is kind of cool. Here we don't have to, so just to kind of get at what I'm saying here, this top equation, the slope-intercept form, would be negative, let's say negative x over 7. Actually, I don't want to say it that way. Let me say negative 1/7 x plus, well, let's just leave that as 24 over 7. It's probably the easier way. But so that's the slope-intercept form of this equation. That's tough to deal with. Not only do I have a fractional y-intercept, but even when I use my slope and I go down 1 and over 7, I'm going to be at a fractional point there. So it's kind of tough to graph those, but doing it this way is a lot easier. Okay. So for the next two, I'll go ahead and do those. On this one, I notice that my y's are again set up to be eliminated. There's a positive one and a negative one, so I'm going to add the equations. Negative 8 plus negative 1 is negative 9x. My y's cancel. And negative 17 plus 26 is positive 9. So that tells me x is negative 1. Now I can use that x equals negative 1 in one of the original equations. I get to pick which one. It doesn't matter which one. Most people would look at this and probably pick the first one. Sorry, the second one. So I get negative 1. Remember, I'm substituting in for x minus 5y equals 26. Negative 1 is positive 1. And when I solve that for y, I'm going to have negative 5y equals 25. And y will equal negative 5. If you get something different, if you have worked it out and done something, notice that you've done something wrong, I always check, which one did I solve for first? And if that one is wrong, I need to look up here to make sure I did this part right. Because if you mess up on your first variable, there's no way you're going to get the right answer for your second one. Okay. Then if I notice, well, I got the first one right, but I messed up on the second one, that's when I'm looking at this second part down here. But I get an answer of negative 1, negative 5. On the next one, every other problem we've eliminated y. Well, y's aren't really set up too nicely. I've got a 4 and a negative 2. But on my x's, I have a 2 and a 2. So I'm going to eliminate my x's. Now, instead of just subtracting, this is one way that you can do it, but I'm going to think about a different way. Because that's sometimes hard to remember to go 1x minus 3x. That's not always the easiest way. Instead, I'm going to multiply the entire bottom equation by a negative 1. Okay? I'm going to copy down the first equation because I'm not doing anything to that. You got to be careful not to run out of room here. But I'm going to copy the first equation, and then the second equation, I'm multiplying everything by a negative 1. All that's going to do is change the signs. So that's going to make it a negative 2x, a positive 2y, and a negative 26. Some people will just go through and, for instance, change the signs like this. I don't really like doing it that way because I want to keep that original equation looking how it started in case I want to use that in my second, solving for my second variable. So now that it's set up, now that I have opposites here, I can add the equations. And so I'll do that. 2x and 2x and negative 2x cancel out. 4y and 2y is going to give me 6y. And negative 22 and negative 26 is going to give me negative 48. So solving for y, I get y is negative 8. And then I can go back and plug that into one of my equations. In fact, I am going to pick the original bottom equation. I don't like it with those negatives in there. This one only has one negative, so it's a little bit easier. Excuse me. Remember, I'm plugging in for y, so we're going to have negative 2 times negative 8 here equals positive 26. So 2x, negative 2 times negative 8 is plus 16 equals 26. Solving that two-step equation, I get 2x equals 10. And so x equals 5. So my answer for this one, 5, for the x, negative 8 for the y. So those two lines cross at 5, negative 8. Pretty interesting stuff. So now what we're going to look at is if we are not set up at all. Notice I don't have any numbers that are the same or opposites. So I can do that same kind of thing that I just did, and I can adjust one of my equations or both of my equations if I need to. In this case, I'm going to change the top equation. I'm going to turn negative 9 into negative 18. I kind of think of this as in the fraction world, finding common denominators, which one is the easiest to do. I could eliminate y's if I wanted to, but I'd have to multiply this one by probably 10 and multiply this one by 7. But I don't want to do that. The main thing to make sure that we do is that whenever we change an equation, we change the whole equation. Otherwise, it's not the same. I can't just change the x's and leave the rest of this stuff how it is. I do have to multiply the whole equation by a number. So that's going to turn this into negative 18x. 2 times negative 7 is negative 14y. And negative 19 times 2 is going to be negative 38. Since I'm not doing anything to the bottom equation because I left this blank, I'm going to go ahead and just copy it down. And now I can go ahead and add my two equations. My x's cancel. I get negative 4y. And here it looks like I get a negative 16. In that case, y is equal to 4. All right, now I'm going to take that y equals 4, and I could plug it into this equation that I made. I typically don't like to rely on things that I made because I feel like that's increasing the possibility of making a mistake. But you can pick any equation you want to. Maybe we pick the bottom equation. There's not as many negatives in there. Life might be a little bit easier. I know the numbers are a little bit bigger, but it really doesn't matter which equation you pick. So plus 10 times 4. That's why I'm substituting in. That's going to equal 22. So I get 18x plus 40 equals 22. And 18x, when I subtract 40, I actually get negative 18. So that tells me that x equals negative 1. So my answer is going to be negative 1, 4. Okay. For the next one, I noticed that I can't turn 2 into 3, or 5 into 3, or 3 into 5, or 3 into 2. So thinking about common denominators, I would have to multiply both these equations by something. So I'm going to multiply the top equation. I'm going to try to eliminate x's. That's what I'm going to focus on. So I'm going to focus on my x's. In order to find a common denominator, if we were doing it like that, it would be 6. So I'm going to multiply the top equation by 3. And since remember, I don't really like to subtract if I can avoid it. So I'm actually going to multiply the bottom equation. I could multiply it by 2 and subtract. I'm going to multiply it by negative 2. So that I get a 6 here and a negative 6 here. Then I can add them and they will eliminate. So it's always important to have your plan ahead of time. Don't think of it as as you're going. Okay, come up with a plan before you start. So 6x plus 15y is going to equal negative 30. And then this one by negative 2, so negative 6x. And minus 6y is going to equal negative 24. When I add these now, my x's will cancel. It looks like I get 9y. And that's going to be equal to negative 54. So then y equals negative 6. And with y equal to negative 6, we can plug that back in. And again, you can pick one of these equations if you want to, but all you did was make the numbers bigger. So that seems like a lot of work. Let's pick the bottom equation. I don't know. It doesn't matter. But we're going to pick the bottom equation. 3x plus 3 times negative 6 equals 12. So 3x, 3 times negative 6 is negative 18. And that's going to equal 12. When I add 18 to both sides, I get 30. And that's going to tell me that x is 10. So I get the answer 10, negative 6. Okay. So not too bad. On these bottom two, I gotta do some work. There's definitely going to be some work involved. You can definitely either choose X or Y on this one. I think I'm going to go with the Y's. Kind of went through the Y there, but that's okay, because I know I can turn 7 into 14 pretty easily. I do notice they're both negatives, so I'm actually going to multiply it by a negative 2. So I'm going to multiply that one by a negative 2. And that's going to give me negative 6x plus 14y equals, that would be 60, so 58. And then I copy down the second equation, minus 14y equals negative 23. So when I add those two equations, negative 6 plus negative 1 is going to be negative 7. My y's cancel, that's what I wanted. And we get 35 over here. When I divide by negative 7, that's going to tell me x equals negative 5. With x being negative 5, I'm going to pick even though there's a bunch of negatives, I'm going to pick the bottom equation here. So I have negative 5 minus 14y equals negative 23. Negative 5 is going to be 5 minus 14y equals negative 23. And so that's negative 14y. I'm going to subtract 5. That's going to give me negative 28. Tells me that y is 2. So my answer, negative 5, 2. Last one here. You know, again, you got to choose X or Y. It really doesn't matter. There's probably an easier one and a harder one. And just like in finding common denominators, I could always just, like, say I picked X, or let's say I picked Y, and I'm going to focus on Y also. I could multiply the top equation by 6 and the bottom equation by 9. Only downfall to that, I'm going to get some pretty big numbers. Instead, I know that I can turn each of these into an 18. Okay? The way I turn 9 into 18 is multiply it by 2. And I would turn 6 into 18 by multiplying by 3. Then I would notice that they're both the same sign. So I do want to switch the signs, and I'll switch the signs of this one. So I'll multiply it by a -3. Okay? This process here is just helping me keep my own head straight in what I want to do. And it's very, you know, it might be a lot of work, it might seem like a lot of work, but I'm just doing it to help myself out. So multiplying that one by 2, I get 4x plus 18y equals -4. And then negative 21x minus 18y equals positive 21. When I add those two equations, my x's are going to be, it's going to give me what, -17. -17x. My y's cancel, that's what I wanted, and that's going to equal 17. And so that tells me that x is -1. When I plug in my -1 into one of the equations, again, I've got 4 to pick from. I think the top one, the original top one, is the easiest. 2 times -1 plus 9y equals -2. So I get -2 there. And I copy down the rest. When I add 2 to both sides, I do get 9y equals 0, which means y equals 0. So again, my answer, -1, 0. Okay. I would like to see your answers as ordered pairs, as that's reassuring what the solution to a system of equations is, being that it is the intersection point between two lines, rather than just saying x is -1 and y is 0. That feels like it's two answers, where you do need to find two answers to figure this out. I want to reassure us of what it really means, and it means that those two lines intersect at the point -1, 0. Thanks for watching. Just remember, get your assignments done, be ready for the Mastery Challenge, and we'll see you in class.